In this video, we'll look at the nucleophilic substitution mechanism for the reaction between a halogenoalkane and cyanide ions to produce a nitrile and a halide ion. The reagent and conditions would be potassium cyanide dissolved in ethanol. Ethanol is used for two reasons. It's a solvent for both the halogenoalkane and the cyanide ion, and also it reduces the amount of water molecules so that you don't have water molecules there as they are nucleophiles as well, and you would have a competing reaction. So ethanolic or alcoholic potassium cyanide will mix very well with the halogenoalkane. So halogenoalkanes react in nucleophilic substitution reactions because the very electronegative halogen atom, or the more electronegative halogen atom, will attract the pair of electrons in the covalent bond towards it, forming a polar bond, the halogen being delta negative and the carbon is delta positive. That means that a nucleophile, such as the cyanide ion, will be attracted to the delta positive carbon. The part of the cyanide ion that makes it a nucleophile is the lone pair on the carbon atom of the nitrile. You don't need to draw the triple bond in your mechanism. I've just drawn it to show that it is there. And the lone pair, and I will put my negative charge on my carbon. The pair of electrons, this lone pair of the nitrile on the carbon atom, will form a bond to the carbon of the halogenoalkane. That will force the two electrons on the carbon halogen bond onto the halogen atom. That forms, if we follow these arrows through, my cyanide is now covalently bonded to the carbon atom. These two electrons are coming to form a bond between this carbon of the nitrile and this carbon of the halogenoalkane. Whatever else was bonded to the carbon will still be bonded to it, and we will have also produced the halide. So the halogen atom has been booted out as a halide. If you want to put the lone pair on, you can, to show that they're the two electrons that came from the bond onto the carbon. They're not 100% necessary. How about an example? Let's say should we go for iodomethane? Let's go for iodomethane. So there it is, iodomethane. Reacting with potassium cyanide. This time I didn't bother with the triple bond. I have to have my negative charge. I have to have my lone pair. I will draw why I have a polar bond here, or the fact that I have a polar bond. Delta positive halogen, delta negative halogen, delta positive carbon. The pair of electrons, this lone pair is going to go to form a bond to that carbon. Those electrons are going to be kicked out onto the halide. Not quite happy with that arrow because it should be pointing a bit closer towards the carbon. There we go. To form my product, my organic product. Now this reaction is very important because, as you may notice, my organic species that I've produced contains one extra carbon. So it is ethane nitrile. This is a very important carbon chain lengthening reaction.